Okay, students. Now we'll start a new topic, and which is very important topic also for the GATE examination point of view, and that is information theory. Very easy, interesting, and important also. Okay. So information is nothing but bits, right? Ones and zeros. Okay. So now this concept, why this concept comes in picture? This concept is used to transmit. This concept is used to transmit non-electric discrete signals. Non-electric discrete signals through a digital communication system. To transmit non-electric discrete signals through a digital communication system. Now this information theory concept is used, like fax machine, transmitting, sending a SMS. Okay. Now these non-electrical discrete signals are transmitting to a digital communication system. Now this concept of information theory is utilized. Okay. So you know that the information, because some unpredictable data. Okay. So if you're tossing a coin, okay, if you toss a coin, if you take an event, now the outcomes are head or tail. Okay. So now the outcome of getting head and the probability of getting head and the probability of getting tail on the coin. Okay. So we will take the outcome with the help of probability. Okay. Now we can get if you're tossing a coin, it may be getting as a head or a tail. So how much probability the head will have, how much probability the tail will have. So based on that probability, so we convert now this event into an information. Okay. So this is an event which is tossing a coin or rolling a die. Now this event is completely, now the outcomes of this event is depends upon probability. So based on this probability, now this event outcomes, this event is tossing a coin, head or tail. Now this event, head or tail, now this event is converted into information with the help of probability. Now the information associated with an event is completely depends upon the probability. Therefore, the information associated with an event, is inversely proportional to probability of occurrence. Am I not? So probability of occurrence, if you remove this probability, we'll put a constant. Now this is the constant, which is nothing but log 1 by p base b. Okay. Now if this base is 10, the information units are decades. If base is e, the information units are nats. If base is 2, binary 1 and 0, the information units in terms of bits. So we'll take information which is nothing but log 1 by p, base is 2, and the units are bits, binary 1 or binary 0. Clear now? So if the probability of error is less, information is more. If the probability of error is more, information will be less, lost. Am I not? So you know that the probability of event is always, the probability of an event is lies between 0 to 1. If not possible, probability is 0. Sum of all the possible events is equal to the total occurrence, then the probability equal to 1. And probability P is always positive. You know that. Okay. So this is the information theory concept, converting into a non-electrical discrete signals into a ones and zeros, which is nothing but in terms of information. Okay. So the average amount of information, the average amount of information, the average amount of information is called as, the average amount of information is called as entropy. The average amount of information is called as entropy H, which is equal to summation I equal to 1 to m probability of that event, and it is converted into information log 1 by p base 2. This is bits per symbol. Bits per symbol means now a source X generating a symbols m1, m2 and so on mn with probabilities p1, p2 and so on with pn, then the average amount of this information is called as entropy, therefore bits per symbol. Okay. Now you know that the number of bits generated per second is called as bit rate. What is bit rate? The number of bits generated per second. Bits per second is bit rate. Now the number of symbols generated per second, symbol rate. The number of symbols generated per second, symbol generated per second, symbol rate. Okay. The number of bits generated per second is called as bit rate, represented by RB. The number of symbols generated per second is called as symbol rate, represented by small r. Okay. The number of symbols generated per second. Now information rate. Information rate, capital R or H dash. The information rate. Now while calculating the information rate, entropy should be multiplied with symbol rate. What is entropy? Bits per symbol. Now what is symbol rate? Symbols, number of symbols generated per second. Now this single symbol cancel. Now this is nothing but bits per second. The information rate, the number of bits generated per second over a discrete channel. Now this is called as information rate, or we call it as a bit rate, which is nothing but number of bits generated per second. Okay. Now we'll find first maximum entropy. Maximum entropy. How to calculate maximum? We know entropy, average amount of information that a source produces, but I want a maximum entropy of a source producing. Okay. Now how to find the maximum entropy and all these things we will see. First you note on this. Now for finding a maximum entropy, I will take one example as binary source. I take a binary source. I just take a binary source. The binary source generating two symbols x1 and x2. Now with probability, if one is p, another one is 1 minus p. Now this is 1 and this is 0 with a probability of p and 1 minus p, because sum of all the probability is always 1. So this is the symbols and this is their probability. Then you tell me how to find the entropy. The entropy H, which is equal to p log 1 by p base 2 plus 1 minus p log 1 by 1 minus p base 2. This is entropy of a binary source. But what I want a maximum entropy. For finding the maximum value, you want to differentiate this entropy with respect to probability and equate to 0. If you differentiate this value and with respect to probability and equate to 0, you can get a root, that root p, which is equal to 1 by 2. Now substitute this p in H. You can get H maximum as, what is H maximum? Which is equal to 1 by 2 log 1 by 1 by 2 base 2 plus 1 minus 1 by 2 log 1 by 1 minus 1 by 2 base 2. Therefore, which is equal to 1 by 2 log 2 base 2 plus 1 by 2 log 2 base 2. Therefore, now which is nothing but 1. Okay, 1 by 2 plus 1 by 2. So, the maximum entropy of a binary source is 1. Now, if you draw the entropy versus, if you draw a entropy versus probability diagram, now you know that the probability is always lies between 0 to 1. So, this is the probability which is lies between 0 to 1. Now, the probability which is lies between 0 to 1, now when the probability which is equal to 1 by 2, when a probability which is equal to, when equiprobable, when a probability equal to 1 by 2, then this binary source which generates maximum entropy. The binary source which is generating the maximum entropy, H maximum, which is equal to 1. Okay. So what is the meaning of that? So what we can understand, the binary source is generating the maximum entropy when that source generating symbols are having equiprobable. Am I not? Now if P equal to 1 by 2, now symbol x1 is symbol x1 occur with a probability of 1 by 2, then symbol x2 is also occur with a probability of which means 1 by 2. What is the meaning of that? So the source generating maximum entropy, that means that source generated symbols are having equiprobable. Now here the two symbols, therefore binary source generating two symbols, so the equiprobable of each symbol is nothing but 1 by 2. If it is 3 symbols, equiprobable is 1 by 3. 4 symbols, equiprobable is 1 by 4. So based on this, then we will construct maximum entropy for any source. So now we want to find the maximum entropy of any source. The maximum entropy of any source, can I write like this? Log m base 2, where capital M is total number of symbols. Total number of symbols. Now we will see this one is correct or not. Okay, this formula is correct or not. So how many symbols here? So M is nothing but total number of symbols. Now there are two symbols. Okay, so let us substitute 2, which is nothing but log M equal to 2 for a binary source. So what is the value? So how much you are getting? Yes, the maximum entropy of a binary source is 1 because M is 2 symbols. So which is nothing but, this is the maximum entropy of any source. H maximum is nothing but log M base 2, where M is total number of symbols. This answer is possible in only one condition. What is the condition? All the symbols produced by that source are having, all the symbols produced by that source are having equiprobable. All the symbols generated by that source are having equiprobable, then that source generates maximum entropy. Means there are m symbols, therefore each symbol is having a probability of 1 by m. So there are 10 symbols, each symbol is having a probability of 1 by 10. Then that source is generating maximum entropy. Okay, this is the maximum entropy concept. No doubt. So this is the way you can calculate the maximum entropy. Now what is the maximum information rate? The maximum information rate. The maximum information rate is nothing but R maximum or H dash maximum. This is the maximum information rate. Now the maximum information rate, which is nothing but R maximum or H dash maximum, is nothing but maximum value of what is the information rate? Symbol rate multiplied with entropy. Now R is cancel, R is symbol rate is a constant value. Therefore this is H maximum. Therefore the maximum information rate, which is nothing but R into what is H maximum? Just now we can find one formula, log m base 2 bits per second, right? Now the maximum information rate, this is the maximum information rate. The maximum information rate is called as channel capacity. The maximum information rate is called as channel capacity. Now the channel capacity C, which is equal to R into log m base 2, the maximum information rate is called as channel capacity. The maximum information rate is called as channel capacity, R into log m base 2 bits per second. Now we will solve a small problem. A discrete source generating three symbols x1, x2, x3 with probabilities. A discrete source generating three symbols x1, x2, x3 with probabilities 1 by 2, 1 by 4 and 1 by 4. A discrete source generating three symbols with probabilities x1, x2, x3 with probabilities 1 by 2, 1 by 4 and 1 by 4. Now he is asking, now determine entropy. First we will find entropy with a symbol rate is also given. Now symbol rate, which is 3000 symbols per second. This is given. This is the given information. Now first we will find the entropy. What is entropy? Now entropy H, which is equal to summation I equal to 1 to m pi log 1 by pi base 2. Therefore entropy H, which is equal to 1 by 2 log 2 base 2 plus 1 by 4 log 4 base 2 plus 1 by 4 log 4 base 2. Therefore which is equal to, now this is entropy, which is 1.5 bits per symbol. Now what is information rate? The information rate R, which is equal to symbol rate multiplied with entropy, which is equal to 3000 symbols per second into entropy is 1.5. Therefore which is equal to 4500 bits per second. Now this is for bit rate or information rate. Okay, we call it as a bit rate or a information rate. And a maximum entropy, the maximum entropy, which is equal to log m base 2. Okay, where m is total number of symbols. The total number of symbols are 3, which is equal to log 3 base 2. Okay, this is the maximum entropy. Now the maximum entropy is possible when all symbols are having each symbol is having a probability of 1 by 3. Now these symbols are having equiprobable, then that source generating maximum entropy. This is the maximum entropy, and the channel capacity, which is equal to R into H maximum, which is equal to R into H maximum. R is 3000 into H maximum is log 3 base 2 bits per second. This is the channel capacity. Okay. Information rate is nothing but how many number of bits are transmitted through a channel. Channel capacity is nothing but the maximum capacity that the channel can withstand, that the channel is capable to transmit. Suppose the information rate is 10 bits per second, means now the number of bits transmitted through the channel is 10. But the channel capacity is 100 bits per second, means the channel is having a capable to transmit 100 bits. Okay, that is the information rate and channel capacity. This is the maximum limit that the channel is capable, and this is how many are transmitting through the channel. Okay, like this. So the information rate or a channel capacity is nothing but efficiency or utilization factor. Information rate over a channel capacity is called as a utilization factor or channel efficiency. Channel efficiency or utilization factor. Now the efficiency is 500 number of bits are transmitting, and the capacity is 4750, like for example. Okay, now how much it is? Now which is nothing but 0.94. Therefore the channel efficiency or utilization factor is 94%. Now this is means the 94% of the channel capacity we are utilizing, utilization factor. Then what is the redundancy? Redundancy, the redundancy, which is nothing but 1 minus channel capacity. So 1 minus 0.94 means 0.06, which means so 6% is the redundancy, not utilizing capacity, and 94% is the capacity of utilizing the channel. Okay, no doubt. This is a small problem, okay? Just for overview I am giving this, but this is not. We will move further, okay? Now see here, this X is one discrete source. This Y is another discrete source. This X is one discrete source. Now let us say this is a transmitter. Now this Y is a discrete source. Let us say this is a receiver. Now there are two discrete sources, X and Y, where X is transmitter, Y is receiver. Now this transmitter transmitting X1, X2, X3 and so on, XM symbols. Now this discrete source receiver receiving Y1, Y2, Y3 and so on, Ym. Okay. Now this is this you can read it, okay, throughout this discussion. Now there are two discrete sources X and Y generating symbols X1, X2, X3 and so on, Y1, Y2, Y3. Now this is a transmitter and this is the receiver. X1 is transmitting, Y1 is received. X2 is transmitting, Y2 is received. Or Y1 is received when X1 is transmitting. Y2 is received when X2 is transmitting, like that. Okay. So this is a discrete source X and Y generating symbols X1, X2 and so on. Okay. Now we will see a few formulas which are very important. Now the concept is joint and conditional entropies. What is it? What is joint? Joint means h of x comma y, right? Now next one is condition. What is condition? H of y by x or h of x by y, because you know the probability concept, that's why I am writing it. Okay. Now what is a joint and conditional entropies? Then we'll find a few formulas here. Now first you tell me what is the entropy of source x. The entropy of source x, which is nothing but, I just take minus symbol, means summation. Now this is pi log 1 by pi base 2 I equal to 1 to m. Sorry. P of this we can represent it as I equal to 1 to m. This I represented as j equal to 1 to m. Okay. Now this is P of xi log P of xi base 2. Now what is the entropy of source y? H of y, which is equal to minus summation j equal to 1 to m P of yj log P of yj base 2. Okay. Now this is entropy of a source x, entropy of source y. Okay, individually. Now we'll see the joint h of x comma y. What is h of x comma y? Minus summation I equal to 1 to m summation j equal to 1 to m P of xi yj log P of xi yj base 2. Now this is a joint entropy. Is it right or not? Now we'll see the conditional entropy. Now this is the second one. Now this is the third one. h of x by y, which is equal to minus, this is the conditional entropy, minus summation I equal to 1 to m summation j equal to 1 to m p of xi yj comma log p of xi by yj, or a conditional entropy of h of y by x. Now h of y by x, which is equal to minus summation I equal to 1 to m summation j equal to 1 to m p of xi yj log p of yj by xi base 2, all are bits per symbols. And there is a relation between joint entropy and conditional entropy. Now that is h of x comma y, which is equal to h of x plus h of y by x. h of x comma y, which is equal to h of y plus h of x by y. This is the joint and conditional entropies. Okay, note down. Because then earlier actually only the question is entropy, information rate, channel capacity, the maximum entropy, that is over. Okay, but later this will be revised and in the gate examination some part is added, and this is the joint and conditional entropies, and all these things are important. Okay, so for solving this, then we required some basic formulas of probability. You are very familiar with that. That's what we'll directly go to the problem solution. So summation I equal to 1 to m p of xi, which is equal to 1, summation j equal to 1 to m p of yj, which is equal to 1, summation I 1 to m summation j equal to 1 to m p of xi yj, which is equal to 1, summation I equal to 1 to m p of xi comma yj, which is equal to p of yj, summation j equal to 1 to m p of xi comma yj, which is equal to p of xi. And one more formula is also important. Now see here, p of xi comma yj, which is equal to p of xi into p of yj by xi, or another one, p of xi comma yj, which is equal to probability of yj into probability of xi by yj. Now these are the probability, which is nothing but this theorem is called as Bayes theorem. Okay, this is called as Bayes theorem. Now a relation between probability and conditional probability and joint probability. Now these are the conditional entropies and joint entropies. Okay, remember the difference. This is probabilities. Now this one is joint entropies, but he is not asking probabilities. He is asking entropies. Okay, now we'll solve the problems. First, you note down these formulas. Now we'll solve one problem which will cover all these conditional and joint entropies. Okay. Now this is the question which is given. Consider the joint probability. First you listen the question carefully. He is giving probabilities. He is asking entropies. Okay. Consider the joint probabilities of two discrete source x and y. Consider the joint probability means p of x comma y of two discrete source x and y given as 3/40, 1/40, 1/40, 1/20, 3/20, 1/20, 1/8, 1/8, 3/8. Consider the joint probability of two discrete sources x and y is given. Now he is asking calculate all the entropies. Okay. Now he is asking to find all the entropies. Now first of all, if you want to find h of x, entropy of a source x, we required probability of symbol x1, probability of x2, probability of x3. So how to get the given is a joint probability, so it's not a problem. The given is a joint probability. So first you can find p of x1. What is p of x1? P of x1, which is nothing but 3/40 plus 1/40 plus 1/40, which is equal to 5/40. Now p of x2, which is equal to 1/20 plus 3/20 plus 1/20, which is equal to 5/20. Now p of x3, what is p of x3? 1 by 8 plus 1 by 8 plus 3 by 8, which is equal to 5 by 8. Now this is P of x1. Now here itself we can easily find h of x, entropy of a source x. What is entropy of a source x? Entropy of a source x, which is equal to, this is the formula, okay? Now entropy of a source x, if you take minus, then you can take probability directly, otherwise this is 1 by, okay? So I can take sign of minus 5 by 40 log 5 by 40 base 2 plus 5 by 20 log 5 by 20 base 2 plus 5 by 8 log 5 by 8 base 2. Now this is entropy of a source x, which is equal to 1.3 bits per symbol. Now entropy of a source y. So for finding entropy of a source y, first we want to find P of y1. What is P of y1? Now sum of all these columns, okay? 3 by 40 plus 1 by 20 plus 1 by 8. Now P of y2. What is P of y2? 1 by 40 plus 3 by 20 plus 1 by 8. P of y3. P of y3, which is equal to 1 by 40 plus 1 by 20 plus 3 by 8. Now which is nothing but now this is 1 by 4, 3 by 10, 9 by 20. Now what is h of y? Entropy of a source y. This is entropy of a source y, which is equal to h of y. H of y, which is equal to minus of 1 by 4 log 1 by 4 base 2 plus 3 by 10 log 3 by 10 base 2 plus 9 by 20 log 9 by 20 base 2. Now this is h of y, which is equal to 1.54 bits per symbol. Now this is the entropy of a source x, entropy of a source y. Now we want to find joint entropy. What is the joint entropy? H of x comma y. You tell me how to find h of x comma y. A joint entropy, if you want to find, we require joint probability. Already the question is given joint probability itself. Okay. So which is nothing but minus of 3 by 40 log 3 by 40 base 2 plus 1 by 40 log 1 by 40 base 2 multiplied with 2 plus 1 by 20 log 1 by 20 base 2 multiplied with 2 plus 3/20 log 3/20 base 2 plus 1/8 log 1/8 base 2 multiplied with 2 plus 3/8 log 3/8 base 2. Now this is the joint entropy. For finding joint entropy, we want joint probability. Already joint probability is given. Then if you simplify, now this joint entropy, which is nothing but 2.67 bits per symbol. But he is asking to find all entropies. All entropy means we just finished entropy of a source X, entropy of source Y, and joint entropy. But we want a conditional entropy also. But if you see here, for finding the conditional entropy, we require joint probability as well as conditional probability. But the question is not given the conditional probability. The question is given only joint probability. So we need to find a conditional probability with this procedure. It will take more time. Why not? It will take more time. Now instead of that, we have one method here. Now what we want? We want to find conditional entropies, right? Conditional entropies. Now see here, there is a relation between joint entropy and entropy of a sources. Okay. So from here I can use this one. So I can utilize this, which is nothing but h of the conditional entropy h of y by x, which is equal to h of x comma y minus h of x. What is the joint entropy? Just now we are calculating 2.67 minus entropy of a source x, which is equal to 1.3, which is equal to 2.37 bits per symbol. Now entropy, the conditional entropy of a source x, which depends upon y, which is equal to h of x comma y minus h of y. Now this is already have joint entropy 2.67 minus entropy of a source y, which is equal to 1.54, which is equal to 2.13 bits per symbol. Now all the entropies, conditional entropies are available, joint entropy is available, entropy of a source x is available, entropy of a source y is also available. Okay, no doubt. Clear or not? Now this is the way you can calculate all the joint and conditional entropies.